This is Nachimali Stella Makara University student working on a project named Smart IoT for real-time mosquito, for real-time wing-beat acoustics, and ISF laser control for malaria vector. And this is a presentation on the deployment of this smart mosquito trap. So in our problem space, we have households that are mainly in the rural areas, hotels, hospitals that are greatly affected by this malaria vector. Moving on, so our main purpose is to combat or control the spread of malaria, which is a very harmful vector in our community, which has some health impact, economic impact, and then the social impact. So we have users, stakeholders, and ecosystem actors. So in our system, in our smart mosquito trap system, our users will definitely be the households and families, hotels, schools that are at greater risk of being affected by this vector. And then we also have the secondary stakeholders like the NGOs, the public health organizations. So in the stakeholders, these are mainly the beneficiaries. They have a way they benefit from this system. So moving on, our data sources, the various sources we use to collect our data included the open data set, like the Hamburg data set, which we mainly used to train our model, so as to be able to detect the malaria causing vector. And then we also have the community contributions through data shared by households, health workers, and field researchers. Still on the data sources, we had different steps we went through in evaluating the data. We went through data collection, we cleaned the data, we validated the data, we stored the data, and then later we did our implementation to fit what we exactly needed for that model or system to evaluate. So moving forward with our value mechanism, which include the social value, commercial value, and the scientific. So in our social value, the system enables real-time mosquito population tracking and easy outbreak prediction. We also have the commercial value, whereby the data-driven insights can be monitored, we can get some value through, we can get some money value through our partners, like the public health agencies, NGOs. So this is mainly the commercial value. And then you have the scientific value. Our system contributes to that, to mainly the scientific databases for future mosquito research. So the scientific value, our data sets will definitely be of use to future research. So in the solution and AI system description. So in building our AI system, we made sure that it is able to capture input, which is the raw audio recordings from the mosquito flight, and then the output, which will be the detection of the vector, and classify it as a mosquito or any other sound to differentiate it. And then we also have the core algorithms. These algorithms that help us in building that model. So we had the feature extraction for mainly classification, the machine learning bit. So that's mainly a brief description of our model. As we continue with metrics, we have some technical metrics and ethical metrics. Technical include the accuracy, where we got the accuracy, and then we have the reference score, where we got the precision, the recall, all that. We were able to get that, and then the latency, we got the throughput, and then the error rate. So we have another metric which is ethical success. So ethical success mainly looks at the fairness. Is this system fair? How will it be deployed? And then we have some bias mitigation. We're able to combat the bias mitigation. Moving forward with the metrics, we have some user connection metrics, which include the adoption rate, the session duration, user certification, among others. We also have the business and the financial metrics, which is the endpoint, this is the gist of the matter, whereby we look at the financial bit of it. What are we going to gain out of it? How are we going to conduct this business? So in the financial metrics, we have the customer acquisition cost. This should be low to enable the customers to easily acquire our system. We also have the lifetime value. So this system is really durable, so it will cover a very long time. So it is very advisable to use. Moving forward, there is a revenue growth among others. So the unfair advantage and differentiation, we have a proprietary acoustic dataset whereby the labeled wing bit sounds optimized for diverse and real-time world noise. We also have the field validation loop, whereby we mainly focused on our micro SCD which was the best trained model we had, besides the FNN, which we also trained, the GAT. So the SCDNet was the best model. So it was highly efficient and a small footprint MSC and small footprint micro SCDNet enables low cost and low power edge computing, which is very rapid and scalable deployment. So it is very good to use, and it was the best for our deployment. So moving forward to the channels and distribution. So we aim to distribute this product through NGOs, public health managers, and then the delivery channels through promotions, demonstrations at tech expos, media coverages, and free AIP API and free API integrations for educational platforms. So this is mainly the delivery channels. And then the revenue streams, how we shall be able to collect some money. First will be through selling anonymous and then aggregated and historical vector activity. And then we also have offering expert services on deployment. First will be mainly the revenue streams, how we'll be able to pull out from this deployment or from this system. We also have a monthly or and you feature it to government vector control agencies for access to the cloud platform. So we shall be able to get some fee from the government. So our model deployed. And then we have some key resources. So these are mainly the resources you can use, or the resources we used. Those are, we have human, we have ML engineers or data scientists needed to develop, optimize, and maintain the micro HCD net, the FNN for the classifier. Micro HCD is mainly for the edge model, and then also have the GAT, which is mainly for the spatial risk model. It is used for the spatial geolocation mainly. So that's the brief key resources we have to use, so you can implement if you are to deploy. We have some key activities that we followed. We have some model life cycles, some operational, some product deployment activities whereby we had some designing of the dashboards for our field technicians. So this is mainly our key activities whereby we also have the governance and compliance, some customer focused activities like facilitating knowledge sharing among vector control agencies and how best to use the AI. Some key partners. So we shall mainly partner with telecommunication companies to spread this system, then some cloud service providers like Google Cloud, some research institutions like Google Scholar also have some cost structure you can look at to briefly get the grasp of the implementation, the cost really needed in all this. Also have some governance and ethics and compliance, whereby we have risk management systems, whereby it implements test protocols to validate the safety and the reliability of this system on a device. So that's mainly the governance, the ethics, and then the compliance of our system. In the scalability and so this is mainly a scalable framework. It is very scalable with microservices and containerization, whereby we use some Docker classes for the cloud for the cloud in for the cloud infrastructure. We had some. We shall also have continuous learning on how to better this system, but it really needs. It is good at this point, but it will definitely need some improvements. Yeah, basically that's it. And then we also have some intellectual property and innovations. This is mainly intellectual. It's all about owning our product. So this is our innovation. And then these are the contributors. Finally, thank you for viewing. Have a nice time.